Hello students. Hello. Hello students. Welcome to the live class on electronic configuration. So what is the present concept? Electronic configuration. My screen visible to you? So coming to the electronic configuration. What do you mean by electronic configuration? So in this session we are going to discuss in detail about the electronic configuration. Screen visible to you? My voice is audible to you? Okay. So coming to the electronic configuration can be defined as the distribution of electrons in various available orbitals of an atom in the ground state. So, how to define electronic configuration? It can be defined as the distribution of electrons in various available orbitals of an atom, especially in the ground state. So, especially electronic configuration means, so how the electrons are distributed in various available atomic orbitals is nothing but electronic configuration, and especially we have to consider the ground state distribution. సో ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ అంటే మనకి ఇచ్చిన యాటంలో ఎలక్ట్రాన్స్ ఎలా డిస్ట్రిబ్యూట్ అయ్యాయో అది చెప్పేదాన్ని ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ అంటాం. ఓకే, సో ఇన్ ఎస్పెషల్లీ the electronic configuration will be represented as NLX notation. So electronic configuration can be represented by using NLX notation, where n is the principal quantum number, L is the azimuthal quantum number. So there are certain rules for writing the electronic configuration. Let us see what are the rules required for writing the electronic configuration. There are three fundamental rules for writing the electronic configuration. So electronic configuration రాయాలి అంటే మనం 3 principles follow అవ్వాలి. So what is the first principle? That is half Bose principle. Now, what is meant by Aufbau's principle? Can anyone share? Yes, Aufbau's principle mainly deals with the filling of atomic orbitals with electrons. That means, according to Aufbau, electrons enter into the orbitals in the increasing order of their energies. So, Aufbau's principle enti? Electrons enter into the orbitals in the increasing order of their energies. సో మనం ఏదైనా ఒక యాటమ్ని కన్సిడర్ చేసినప్పుడు దాంట్లోకి ఎలక్ట్రాన్స్ ఎలా ఎంటర్ అవుతాయి? ఏ ఆర్బిటాల్కి అయితే లోయెస్ట్ ఎనర్జీ ఉందో ఆ ఆర్బిటాల్ని మనం ఫస్ట్ ఫిల్ చేయాలి. సో డిపెండింగ్ అపాన్ ది ఎనర్జీ ఆఫ్ ది ఆర్బిటల్స్ the electrons will be filled. So the orbital with lowest energy should be filled first. సో ఏ ఆర్బిటాల్కి అయితే తక్కువ ఎనర్జీ ఉంటుందో అది మనం ఫస్ట్ ఫిల్ చేయాలి. సో హౌ టు క్యాలిక్యులేట్ ద ఎనర్జీ ఆఫ్ ది ఆర్బిటాల్? సో ద ఎనర్జీ ఆఫ్ ది ఆర్బిటాల్ కెన్ బి క్యాలిక్యులేటెడ్ by using n plus L value. సో ఎనర్జీ ఆఫ్ ది ఆర్బిటాల్ని మనం ఫిల్ చేయాలంటే మనం ఇక్కడ ఫాలో అవ్వాల్సిన రూల్ ఏంటి? ఎన్ ప్లస్ ఎల్ వాల్యూ. సో ఆర్బిటాల్ యొక్క ఎన్ ప్లస్ ఎల్ వాల్యూని మనం ఫస్ట్ క్యాలిక్యులేట్ చేయాలి. సో ద ఆర్బిటాల్ విత్ లోయెస్ట్ ఎన్ ప్లస్ వాల్యూ, the orbital with lowest n plus L value should be filled first. మా స్క్రీన్ క్లియర్గా కనిపిస్తుందా? So always the orbital with lowest n plus L value should be filled first. Okay, so let us see one best example. Between 4s and 3d orbitals, which orbital should be filled first? Any guess? For each orbital we have to calculate n plus L value. So for the 4s orbital, the n value is 4, L value is 0, it is 4. And for 3d orbital, the n value is 3 and the L value for the d orbital is 2 and that is equal to 5. So 4s orbital is having lowest n plus L value and hence it should be filled first. So here the 4s orbital should be filled first. Let us see one more example. Between 2p and 3s orbitals, which one should be filled first? Try to guess. Between 2p and 3s orbital, which one should be filled first? 2p. Very good, Swati. So again here we have to follow n plus L value. For 2p orbital, it is 2 plus 1, that is equal to 3. So what is the L value for the p orbital? That is 1. And coming to the 3s orbital, n is equal to 3 and the L value for s orbital is 0 and hence For both 2p and 3s orbitals, the n plus L value is same. Then whenever if two orbitals are having same n plus L value, then we have to fill the orbital with lowest L value. That's why 2p orbital should be filled first. Is it clear about the Aufbau's principle? Next, we will discuss about the Hund's principle. So, according to Hund's, whenever degenerate orbitals are available for electrons, the pairing of electrons takes place only after all the orbitals are filled with one electron each. Can you remember Hund's principle? Yes. Whenever degenerate, try to think what is meant by degenerate. Degenerate orbitals are available for electrons. The pairing of electrons takes place only after all orbitals are filled with one electron each. సో ఎప్పుడైతే డీజెనరేట్ ఆర్బిటాల్స్ అనేవి అవైలబుల్గా ఉంటాయో అలాంటి కండిషన్స్లో ఆల్ డీజెనరేట్ ఆర్బిటాల్స్ని ఫస్ట్ మనము సింగిల్ ఎలక్ట్రాన్తో ఫిల్ చేసిన తర్వాత మాత్రమే పెయిరింగ్ అనేది చెయ్యాలి. క్లియర్? సో వాట్ డూ యూ మీన్ బై డీజెనరేట్ ఆర్బిటాల్స్? So, degenerate orbitals means orbitals having the same energy. So, in the case of p orbital, or we can also consider d orbital, they consist of degenerate orbitals. So, in the case of p orbital, how many degenerate orbitals are available? p orbital లో 3 degenerate orbitals ఉంటాయి. d orbital లో ఎన్ని ఉంటాయి? 5 degenerate orbitals. Degenerate orbitals means having same energy. Degenerate orbitals అంటే ఏ ఆర్బిటాల్స్కి అయితే సేమ్ ఎనర్జీ ఉంటుందో వాటిని మనము డీజెనరేట్ ఆర్బిటాల్స్ అంటాం. ఓకే, సో p orbitals, d orbitals are degenerate orbitals in the absence of both magnetic and electric field. సో అవి ఎప్పటి వరకు డీజెనరేట్గా ఉంటాయి? మ్యాగ్నెటిక్ ఫీల్డ్ కానీ ఎలక్ట్రిక్ ఫీల్డ్ కానీ మనం అప్లై చేయనంత వరకు అవి డీజెనరేట్గా ఉంటాయి. క్లియర్? Let us see one best example. How to write P4 configuration. So, here we have to consider orbital model. So, 3 degenerate orbitals are available. So, according to Hund's principle, all the degenerate orbitals are filled with single electron first. సో p ఆర్బిటాల్లో మనకి 4 ఎలక్ట్రాన్స్ అవైలబిలిటీ ఉంది. సో వాటిని ఫిల్ చేసేటప్పుడు p ఆర్బిటాల్లో 3 డీజెనరేట్ ఆర్బిటాల్స్ ఉన్నాయి కాబట్టి ప్రతి ఆర్బిటాల్లో సింగిల్ ఎలక్ట్రాన్ వేసిన తర్వాత మాత్రమే మనం పేరింగ్ స్టార్ట్ చేయాలి. దిస్ ఈజ్ ద రైట్ కాన్ఫిగరేషన్. సో ఒక్కొక్కసారి ఆర్బిటాల్లో పెయిర్ అప్ చేయకూడదు. ఇట్ ఈస్ ద రాంగ్ ఇంటర్ప్రిటేషన్. సో డీజనరేట్ ఆర్బిటాల్స్లో ఫస్ట్ సింగిల్ ఎలక్ట్రాన్తో ఫిల్ చేసి తర్వాతే పెయిరింగ్ అనేది స్టార్ట్ చేయాలి. ఫర్ ఎగ్జాంపుల్ let us consider D7 configuration. D7 configuration ఎట్లా వేయాలి? D means it consists of 5 degenerate orbitals. So 5 degenerate orbitals లో ఫస్ట్ సింగిల్ ఎలక్ట్రాన్తో ఫిల్ చేయాలి. సో 5 ఫిల్ చేసిన తర్వాత 6th one and the 7th one. So here how many unpaired D electrons are available? 3. Clear? So Hund's rule is highly useful for the filling of degenerate orbitals with the electrons. And according to Hund's, he explained the stability of atoms or ions. So according to Hund's, the atoms or ions with half filled or completely filled configuration are stable. So Hund's principle ప్రకారం ఏ యాటంలో అయితే ఏ అయాన్లో అయితే హాఫ్ ఫిల్డ్ లేదా కంప్లీట్లీ ఫిల్డ్ కాన్ఫిగరేషన్ ఉంటుందో అలాంటి యాటమ్స్ లేదా అయాన్స్ అనేవి స్టేబుల్. ఫర్ ఎగ్జాంపుల్ ఇఫ్ వి కన్సిడర్ ఫాస్ఫరస్, ఇట్స్ అటామిక్ నెంబర్ ఈజ్ 15 and the configuration is 1s2, 2s2, 2p6, 3s2, 3p3. So last orbital configuration in detail is each degenerate orbital consists of one single electron each. So it is half filled and hence this configuration accounts for the stability of phosphorus. ఎప్పుడైతే మనం ఫాస్ఫరస్ కాన్ఫిగరేషన్ చూస్తామో లాస్ట్ ఆర్బిట్ 3p ఆర్బిట్లో మనకి హాఫ్ ఫిల్డ్ కాన్ఫిగరేషన్ ఉంటుంది కాబట్టి phosphorus is more stable. And if we consider helium, its atomic number is 2 and its configuration is 1s2 and it is having completely filled configuration and hence helium is stable because of completely filled configuration. So in that way Hund's principle is highly useful to explain the stability of atoms or ions having half filled or completely filled configuration. And let us move on to the third principle, that is Pauli's exclusion principle. So coming to the Pauli's exclusion principle, can you remember what is Pauli's exclusion principle? Yes. No two electrons in an atom can have same values for 4 quantum numbers. సో పౌలీస్ ఎక్స్క్లూజన్ ప్రిన్సిపల్ ప్రకారం మనం యాటంలో ఏ 2 ఎలక్ట్రాన్స్ని కన్సిడర్ చేసినా 4 క్వాంటమ్ నెంబర్స్కి సేమ్ వాల్యూస్ ఉండవు. సో let us consider one best example, that is carbon. So what is the atomic number of carbon? 6. What is its configuration? S, that is 1s2, 2s2, 2p, 2. So coming to the detailed configuration of the last orbital px1, py1. So the magnetic quantum number values are different, -1, 0, 1. So let us write the quantum number values for px and py electrons, N, L, M, S, and it is 2p1, here it is 2p2. So coming to the first electron, NLX notation, N value is 2, L value, that is p orbital, hence it is 1. M value is, if you carefully observe the detailed configuration, M value is -1 and it is first electron, so plus half. Coming to the second electron, 2p2, its configuration is 2p2 and hence N value is 2, L value is again 1, but coming to the M value, it is 0, S value is plus half. So 3 values are same, these 2 electrons are differ by M value. Clear? So these are the 3 fundamental rules which we have to follow while writing the configuration of atoms. I think you are all familiar with electronic configuration up to 30 elements. At once you try to recollect. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These are the first 10 elements. Will you write the configuration? So atomic number of hydrogen is 1, helium is 2, lithium is 3, beryllium is 4, boron is 5, carbon is 6, nitrogen is 7, oxygen is 8, fluorine is 9, neon is 10. And hence coming to the configuration, 1s1. That of helium is 1s2, lithium 1s2, 2s1, beryllium 1s2, 2s2, boron 1s2, 2s2, 2p1, carbon 1s2, 2s2, 2p2, nitrogen 1s2, 2s2, 2p3. You just try to practice the electronic configuration of first 30 elements. 1s2, 2s2, 2p4. Coming to the fluorine, it is 1s2, 2s2, 2p5. Neon is 1s2, 2s2, 2p6. Moving to the next 10 elements, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, will you practice the configuration? So coming to the sodium, its atomic number is 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17. And coming to the electronic configuration, sodium is 1s2, 2s2, 2p6 and 3s1. Magnesium is 1s2, 2s2, 2p6, 3s2. Coming to the aluminium, it is 1s2, 2s2, 2p6, 3s2, 3p1. Next, silicon 1s2, 2s2, 2p6, 3s2, 3p2. Phosphorus 1s2, 2s2, 2p6, 3s2, 3p 3. Sulfur 1s2, 2s2, 2p6, 3s2, 3p4. And what is the configuration of chlorine? Yes, it is 1s2, 2s2, 2p6, 3s2, 3p5. Coming to the remaining 3 elements, argon, potassium and calcium. What is the atomic number of argon? That is 18. Potassium is 19. Calcium is 20. So configuration will be 1s2, 2s2, 2p6, 3s2, 3p6. Coming to the potassium, 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. Coming to the calcium, it is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. Let us see the configuration of remaining 10 elements. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt. So what is the atomic number of scandium? 21, titanium is 22, vanadium is 23, chromium is 24, manganese is 25, iron is 26, cobalt is 27. And coming to the configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Titanium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Vanadium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. And coming to the chromium, you should be very careful. 1s2, 2s2, 2p6, 3s2, 3p6 and it is not 4s2 but it is 4s1. So if one electron jumps from 4s orbital to the 3d orbital, it gets a half-filled configuration and gains extra stability. So in that way, chromium shows anomalous behavior to account for the stability. And coming to the manganese, 1s2, 2s2, 2p6, 3s2, 3p6. Here it is 4s2, 3d5. Iron 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Cobalt 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. And coming to the remaining elements, nickel, copper and zinc, 28, 29, 30. So what is the atomic number of copper? That is 29. Before copper, let us see about the nickel. 28. Its configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Coming to the copper, its configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and you should be very careful while writing the configuration of copper. So if at all one electron jumps from 4s orbital to 3d orbital, then it becomes 4s1, 3d10. So d orbital gets completely filled configuration and that gives extra stability to the copper according to Hund's principle. Coming to the zinc, its atomic number is 30 and its configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d10. This is all about the configuration of first 30 elements. Emma, is it clear about the electronic configuration? Now we are going to enter into the most important session, That is, we are going to discuss in detail about the multiple choice questions based on electronic configuration, which is very, very interesting. You try to solve each and every question. First question is, be ready. After 3D sub level is completely filled, the differentiating electron enters into which subshell? That is, which sub level? సో 3D సబ్షెల్ ఫిల్ అయిన తర్వాత ఎలక్ట్రాన్ నెక్స్ట్ వచ్చే ఎలక్ట్రాను ఏ సబ్ లెవెల్కి వెళ్తుంది? యూ ట్రై టు ఆన్సర్. So here, depending upon the n plus L value, we can decide the next electron enters into which subshell. So very good, Swati. For 4s orbital, n is equal to 4. For s orbital, L value is 0. Its n plus L value is 4. Coming to the Swati, it's not 4s. You just do the calculation. For 4p orbital, here n is 4. For p orbital, L value is 1 and it is equal to 5. Here you have to calculate the n plus L value for the 3D orbital also. So for 3D orbital, n value is 3, L value is 2. So its n plus L value is 5. So after 3D orbital, which subshell should be filled first? You have to guess. So coming to the 4f orbital, its n value is 4 and the L value for the f orbital is 3 and it is equal to 7. For 5s orbital, here the n value is 5 and the L value for the s orbital is 0. And that is equal to 5. So especially 4p and 5s orbital are having same n plus L value. So in that case, we have to consider n value. The orbital with lowest n value should be filled first and hence 4p orbital should be filled first. So option B is the right answer. Tilak, very good. Next, we will discuss about the second question, that is the atomic number of the electron with maximum number of unpaired 2p electrons in the ground state. ఏ అటామిక్ నెంబర్ ఉంటే దాంట్లో మ్యాక్సిమం అన్పెయిడ్ 2p ఎలక్ట్రాన్స్ ఉంటాయి. సో నేను హింట్ ఇస్తున్నాను. ఇచ్చిన ఆప్షన్స్ అన్నీ అటామిక్ నెంబర్స్. ఆ అటామిక్ నెంబర్స్తో మీరు కాన్ఫిగరేషన్స్ వేయండి. కాన్ఫిగరేషన్స్ వేస్తే ఏ కాన్ఫిగరేషన్లో మనకి 2p ఆర్బిటాల్లో ఎక్కువ అన్పెయిడ్ ఎలక్ట్రాన్స్ ఉంటే అది రైట్ చాయిస్ అవుతుంది. ట్రై చేస్తున్నారా? కాన్ఫిగరేషన్ ట్రై చేయండి. అటామిక్ నెంబర్ 1 కాన్ఫిగరేషన్ ఈస్ 1s1. కమింగ్ టు ద option B, atomic number is 7. Configuration is 1s2, 2s2, 2p3. So you just write the detailed configuration. So here 3 unpaired electrons are present. Coming to the option C, 13. Configuration is 1s2, 2s2, 2p6, 3s2, 3p1. Only one electron is present here. Coming to the option D, 8. So configuration is 1s2, 2s2, 2p4. So detailed configuration. One orbital is completely filled. So 2 unpaired electrons. Coming to the option B, 3 unpaired electrons are present. So option B is the right answer. Tilak, very good. Let us move on to the next question. The electronic configuration 1s2, 2s1, 2px1, 2py1, 2pz1 represents. Electronic configuration 1s2, 2s1, 2px1, 2py1, 2pz1 గా రిప్రజెంట్ చేస్తే అది ఏ ఆటమ్ యొక్క కాన్ఫిగరేషన్ని రిప్రజెంట్ చేసినట్టు? ట్రై చేయండి. హేమచంద్ర, మీరు ట్రై చేయండి అన్న. ఒక ఆటమ్ యొక్క కాన్ఫిగరేషన్ మన 1s2, 2s1, 2px1, 2py1, 2pz1 గా రాస్తే అది ఏ ఆటమ్ యొక్క కాన్ఫిగరేషన్? Okay, it is the configuration of an excited carbon atom. Actually, the carbon atomic number is 6 and its configuration is 1s2, 2s2, 2p2. But in the excited state, one electron will be transferred into the p orbital. So, and it becomes 1s2, 2s1, 2p3. So, excited carbon atom will have that configuration. So, option B is the right answer. Tilak, here two types of carbon atoms are available. One is the ground state and the second one is an excited carbon atom. So, excited carbon atom is the right answer. Clear? Let us move on to the next question. The number of neutrons present in Zn plus 2 ion. Here the mass number is given 65. And what is the atomic number of zinc? If you know the atomic number, then you will get the answer. What is the atomic number of zinc? Can anyone answer? What is the atomic number? 30. Tilak, very good. And how to know the number of neutrons present in an atom? Mahendra, very good. So, can you calculate the number of neutrons present in Zn plus 2 ion? Mass number minus atomic number gives the number of neutrons. That is the hint. Tilak, very good. So, 65 minus 30, that is equal to 35, and hence option A is the right answer. Clear? Moving to the fifth question. An atom differs from its ion in. Is the question clear? An atom differs from its ion in. So, you just consider one simple example, potassium atom and potassium ion. In what way these two, that means potassium atom and potassium ion, are different? Can you guess? Yes, very good, Swati. So, with respect to the number of electrons, potassium atom and potassium ion will differ. So, option C is the right answer. Coming to the sixth question. The valence electronic configuration of copper is. What is the right option? You are supposed to guess the valence electronic configuration of copper. So what is the atomic number of copper? 29. Just now we discussed about the configuration. So what is the configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. So what is the right answer? You are supposed to guess the valence configuration. That is option B, 3d10 and 4s1. Let us move on to the 7th question. Which atom has as many s electrons as p electrons? కింద ఇచ్చిన ఆప్షన్స్లో ఏ ఆటంలో ఎస్ ఎలక్ట్రాన్స్ పి ఎలక్ట్రాన్స్ సేమ్గా ఉన్నాయి? ఎస్. అగైన్ యూ హ్యావ్ టు రైట్ ది కాన్ఫిగరేషన్ వేసి ఏ ఆటంలో ఎస్ ఎలక్ట్రాన్స్ పి ఎలక్ట్రాన్స్ సేమ్గా ఉన్నాయో చెప్పండి. తిలక్, స్వాతి, ట్రై టు ఆన్సర్. Okay, hydrogen 1s1 only s electron is present. Helium 1s2 only 2 s electrons are present. Coming to the magnesium, its atomic number is 12. Configuration is 1s2, 2s2, 2p6 and 3s2. So how many s electrons are present? 6. And how many p electrons are present? 6. So option C is the right answer. In magnesium, the number of s electrons equal to number of p electrons. Clear? Coming to the next question. Nitrogen atom has 3 unpaired electrons in its ground state. It can be explained by the configuration of nitrogen atom can be explained on the basis of which principle? Mahendra, very good. So based upon the Hund's principle, we can explain that the degenerate orbitals are having half-filled configuration are more stable. So the stability of nitrogen accounts for the Hund's principle. Let us move on to the 9th question. The valence electron configuration of an element with atomic number 22 is. You just try to write the. Okay, no problem, Tilak. You try to answer. What is the configuration of an element with atomic number 22? S. So 22 means 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d2. Tilak, you are right. So that is option C, 3d2 and 4s2. Swati, what are you doing? You try to answer. The maximum number of electrons present in the N shell. Try to answer as early as possible. N shell లో ఎన్ని ఎలక్ట్రాన్స్ ఉంటాయి? Principal quantum number n can be represented with numerical values 1, 2, 3, 4 are with alphabets K, L, M, N. So it is N shell means N is equal to 4. And how to calculate maximum number of electrons present in Swati? Very good. Fourth shell by using 2n square formula. So you substitute the value of n here. N square, 4 square, 16 into 2, 32. So option B is the right answer. Tilak, very good. Coming to the 11th question. The number of unpaired electrons in nickel plus 2 ion is. Nickel plus 2 ion లో ఎన్ని unpaired electrons ఉంటాయి? ఫస్ట్ మీరు నికెల్ కాన్ఫిగరేషన్ రాయండి. సో వాట్ ఈస్ ద అటామిక్ నెంబర్ ఆఫ్ నికెల్? 28. And what is its configuration? S. That is 1s2, 2s2. Meanwhile, you try to answer 2p6, 3s2, 3p6, 4s2, 3d8. And here it is nickel plus 2 ion. So 2 electrons are removed from the outermost orbit, that is from 4s orbit, and we have to write the detailed configuration of the 3d orbital. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 3d8 electrons are present. So how many unpaired electrons are present? Swati, very good. 2 unpaired electrons are present. So option C is the right answer. So coming to the 12th question. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4. It corresponds to which atom? త్వరగా ఆన్సర్ చేయండి. Atomic number is 16. Sai, very good. Option C is the right answer. Swati, wrong answer. The following species has the lowest number of electrons in the valence shell. So valence shell లో తక్కువ ఎలక్ట్రాన్స్ ఏ స్పీషీస్లో ఉన్నాయి? సో కాన్ఫిగరేషన్ రాయడానికి ట్రై చేయండి. ఫస్ట్ యాటమ్ రాయండి, నెక్స్ట్ అయాన్గా కన్వర్ట్ చేయండి. సో దట్ ఈస్ క్లోరిన్ యాటమ్, 17 అటామిక్ నెంబర్. కాన్ఫిగరేషన్ 1s2, 2s2, 2p6, 3s2, 3p5. But here it is Cl minus, that means 3p6. Next, coming to the helium, atomic number is 2 and hence 1s2. Very good, Sai. So let us see the remaining species also. Fluoride 1s2, 2s2, 2p6. Sulfur 1s2, 2s2, 2p6, 3s2, 3p4. Lowest number of electrons in the valence shell. So here helium is the right answer. Option B. Coming to the next question. All the 4 quantum numbers cannot be same for the 2 electrons in a single orbital. So according to which principle all the 4 quantum numbers cannot have same value for the 2 electrons present in a single orbital? What is your answer? Mahendra, very good. So according to Pauli's exclusion principle, no 2 electrons in an atom can have same values for 4 quantum numbers, especially the 2 electrons present in the same orbital. They are differed by spin quantum number value. One will have plus half and the other electron will have minus half. Coming to the 15th question, which of the following ions is not isoelectronic with O minus 2? Isoelectronic means containing same number of electrons. What is your answer? Tilak, very good. So Na plus means 10 electrons are present. O minus 2 means atomic number is 8 and minus 2 means 2 electrons are present. So the number of electrons will be 10 for O minus 2. Coming to the Na plus 11 and 1 electron is removed. So 10 electrons are present. Coming to the potassium, its atomic number is 19 and 1 electron is removed. So 18 electrons are present. So option B is the right answer. Anyhow, let us check the remaining species. Fluoride 9 plus 1, 10. Nitride 7 plus 3, again 10. Clear? Let us discuss about the few more multiple choice questions. The set of quantum numbers denoting the highest energy. Very interesting question. The set of quantum numbers denoting the highest energy. ఇచ్చిన క్వాంటమ్ నెంబర్స్లో ఏ ఆర్బిటాల్కి హైయెస్ట్ ఎనర్జీ ఉంటుంది? గెస్ చేయండి. How to calculate the energy of the orbital? By following n plus L value. You just calculate n plus L value, then you will get the right answer. Tilak, at once you check. Yes, here we are supposed to identify the orbital having the highest energy based upon the quantum number values. So 4 plus 2, option C is the right answer. The number of electrons in potassium 1940. Very simple question. What is your answer? Ma, the number of electrons present in potassium. Yes. Very good, Tilak. Option A is the right answer, 19 electrons. I would like to conclude within few minutes. How many d electrons are present in chromium plus 2 ion? Again, here you are supposed to write the configuration of the chromium first, then followed by chromium plus 2. So chromium atomic number is 24 and its configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Remember that 4s1, 3d5. It is chromium plus 2. 1 electron is removed from the s orbital, 1 from the d orbital. So how many unpaired d electrons will be present? 3d4. How many? S. Option C. 4 unpaired d electrons are present. Is it clear? For writing the configuration of any ion, you just write the configuration of the atom. Next you can write the configuration of ion. That's the simple way. ఏ అయాన్ కాన్ఫిగరేషన్ రాయాలన్నా ఫస్ట్ ఆటమ్ కాన్ఫిగరేషన్ రాయండి, దాని నుంచి అవుటర్ మోస్ట్ ఆర్బిట్లో ఉన్న ఎలక్ట్రాన్స్ తీసేయాలి. క్లియర్? In which of the following Aufbau's principle is violated? జాగ్రత్తగా గెస్ చేయండి. ఇచ్చిన 4 ఆప్షన్స్లో ఏ ఆప్షన్లో ఆఫ్బౌస్ ప్రిన్సిపల్ అనేది వైలేట్ అయ్యింది? వాట్ ఈజ్ ఆఫ్బౌ ప్రిన్సిపల్? ఎలక్ట్రాన్స్ ఎంటర్ ఇంటూ ద ఆర్బిటల్స్ ఇన్ ద ఇంక్రీజింగ్ ఆర్డర్ ఆఫ్ దేర్ ఎనర్జీ. నేను ఒకసారి మళ్ళీ ఆఫ్బౌస్ ప్రిన్సిపల్ రిపీట్ చేశాను. దాని మీద బేస్ అయ్యి ఇచ్చిన ఆప్షన్స్లో ఏ ఆప్షను మనకి ఆఫ్ బోస్ ప్రిన్సిపల్ని వైలేట్ అయిందో చెక్ చేయండి. స్వాతి, తిలక్, సాయి, మహేంద్ర, ఒక్కసారి కాన్ఫిగరేషన్ డీటెయిల్డ్గా చెక్ చేయండి. Anyhow, option C is the right answer. Here, without filling the s orbital, the electrons entered into the 2p orbital, and hence here this configuration violated the off-Bose principle. Clear? Let us move on to the last question of today's session, that is, which of the following has more number of unpaired d electrons? So unpaired d electrons ఇచ్చిన ఆప్షన్స్లో దేంట్లో ఎక్కువ ఉంటాయి? యు జస్ట్ రైట్ ది కాన్ఫిగరేషన్ ఫర్ ఈచ్ ఆటమ్. అట్లీస్ట్ outermost configuration scandium 21, so it will be 4s2 3d1. titanium plus, actually it is 4s2 3d2 and 1 electron is removed, so it is 4s1. ట్రై చేస్తున్నారమ్మా. కమింగ్ టు ద ఐరన్, ఇట్ ఈస్ 4s2 3d6 and 2 electrons are removed, so the outermost configuration 3d configuration represents that 1d orbital is completely filled and hence it contains 4 unpaired d electrons. Mahendra, very good. Coming to the copper, it is 4s1 3d10 and it is copper plus this electron is removed, it is completely filled, and hence what is the right option? Option C, that is Fe+2. I would like to thank all the students for attending the class very actively. Swati, Sai, Mahendra, Tilak. That's all for today. Have a nice day. Thank you.